Welcome, students. Today we will explore complex numbers and quadratic equations. In this lecture, we will cover NCERT section 4.5. Then we will solve miscellaneous exercise. Question number 1 to 3. This is our disclaimer. We will begin our discussion with section 4.5 on the argand plane and the polar representations of complex numbers. Then we will solve NCERT miscellaneous exercise question number 1 to 3. I hope you are with your notebooks and pens ready. So let's get started. So we will start by looking at how we represent complex numbers on a plane. Our complex numbers z equals x plus iota times y can be shown as a unique point P with coordinates x, y on a Cartesian plane. Here, x is the real part and y is the imaginary part. So this helps us visualize complex numbers just like we do with points in geometry. So this plane is called the complex plane or argand plane. So you can see in these figures how each complex numbers corresponds to a point. So this emphasized that these visual representations makes it easier to understand operations with complex numbers like addition of two complex numbers, subtraction of two complex numbers, okay, scalar multiplication to a complex numbers. So let's focus on the axis. The x-axis in the complex plane is called the real axis. This is where all numbers with zero imaginary part lie. So any number like z equals x plus 0 times iota will be on this axis. Similarly, the y-axis is called the imaginary axis. This is where all numbers with zero real part are located. So numbers like z equals 0 plus iota times y will be found here in this axis. So this operations helps us to distinguish between the real and imaginary components of any complex number. Next, let's talk about the modulus of a complex number. The length of the vector OP from the origin to the point P with coordinates x, y is called the modulus of z. The formula is modulus of z equals square root of x square plus y square. Here, x is the real part and y is the imaginary part. So this is just like finding the distance from the origin to the point x, y in the plane. Finally, let's talk about conjugate. So let's look at the conjugate of a complex number. So the conjugate of z written as z bar or z with a line over it, and z bar equals x minus iota times y. This means we change the sign of the imaginary part. So geometrically the conjugate is the reflection of z across the real axis as shown in the figure. So look at figure 4.3. In this figure you can see the reflection of the point P x, y with respect to real axis is q of x, minus y. Okay, so z conjugate is nothing but the reflection of z across the real axis. Now let's look at the example. 7. So in this example, we have to find the conjugate of 3 minus 2 times iota times 2 plus 3 times iota divided by 1 plus 2 times iota times 2 minus iota. So here I is the imaginary unit, which means iota square equals minus 1. So the conjugate of a complex numbers a plus b times iota is a minus b times iota. So we will work through this step by step. So let's look at its solution. So we start writing the expression as it is 3 minus 2 times iota times 2 plus 3 times iota divided by 1 plus 2 times iota times 2 minus iota. So this setups our problem and shows us the two complex number in the numerator and the denominator that we need to multiply out. So now let's expand both the numerator and the denominator. So in the numerator, 3 minus 2 times iota times 2 plus 3 times iota gives us 6 plus 9 times iota minus 4 times iota plus 6. And in the denominator, 1 plus 2 times iota times 2 minus iota gives us 2 minus iota plus 4 times iota plus 2. So now notice that iota square equals minus 1. So we will use to simplify further iota square equals minus 1. So after simplifying, the numerator becomes 12 plus 5 times iota and the denominator is 4 plus 3 times iota times 4 minus 3 times iota divided by 4 minus 3 times iota. Here we multiply both the numerator and denominator by the conjugate of the denominator, which is 4 minus 3 times iota. So let's expand the numerator. So 12 plus 5 times iota times 4 minus 3 times iota gives us 48 minus 36 iota plus 20 times iota plus 15. The denominator becomes 16 plus 9. Since 4 plus 3 times iota times 4 minus 3 times iota equals 4 square minus 3 times iota whole square. And remember, iota square is minus 1. So after simplifying, we will get 4 square minus 3 times iota whole square equals 16 plus 9. Now we combine like terms. So the numerator is 48 plus 15, which is 63. And minus 36 times iota plus 20 times iota, which is minus 16 iota. So the denominator is 25. So the simplified result is 63 divided by 25 minus 16 divided by 25 times iota. Now recall that the conjugate of a complex number z equals x plus iota times y is x minus iota times y. So to find the conjugate of our answer, we simply change the sign of the imaginary part. So this is a key property of complex numbers. So therefore, conjugate of 3 minus 2 iota times 2 plus 3 iota divided by 1 plus 2 iota times 2 minus iota is 63 divided by 25 plus 16 divided by 25 times iota. So I hope this example is clear to all of you. Now let's look at question 1 of miscellaneous exercise. So in this question, we have to evaluate iota to the power 18 plus 1 divided by iota whole to the power 25 whole to the power 3. Here, iota is the imaginary unit where iota square is minus 1. So, first of all, try it yourself and then see solution. So let's start the solution of this question. Given that iota to the power 18 plus 1 divided by iota to the power 25 whole to the power 3. So our goal is to simplify this expression. Okay. So here what can we do? We can use here iota to the power 18. We can write as multiply by 4 plus 1 or 2 or 3. Okay. So actually iota to the power 4k is 1. Iota to the power 4k plus 1 is iota. Iota to the power 4k plus 2 is minus 1. Okay. And iota to the power 4k plus 3 is minus iota. Okay. So we can use this concept and then we can simplify this expression. So let's simplify iota to the power 18 and 1 divided by iota to the power 25. So iota to the power 18 can be written as iota to the power 4 times 4 plus 2. And using exponent rule, we can write it as iota to the power 4 whole to the power 4 times iota square. Since iota to the power 4 is 1, iota square is minus 1. So multiplying these together, we get 1 to the power 4 times minus 1 equals minus 1. That means iota to the power 18 equals minus 1. Therefore, iota to the power 18 equals minus 1. So here we simplified iota to the power 18 as minus 1. Similarly, we have to simplify 1 divided by iota whole to the power 25. So now for 1 divided by iota to the power 25, we can rewrite this as 1 divided by iota raised to the power 25. So this makes it easier to simplify using the properties of exponents. So now let's break down iota to the power 25. So we know that iota to the power 4 is 1. So we can express iota to the power 25 as iota to the power 4 to whole to the power 6 times iota to the power 1. Since 4 times 6 is 24 and 24 plus 1 gives us 25. So 1 divided by iota raised to the power 25 becomes 1 divided by iota to the power 4 whole to the power 6 times iota to the power 1. Since iota to the power 4 equals 1, so iota to the power 4 whole to the power 6 is just 1 to the power 6, which is still 1. That means our denominator simplifies to 1 times iota or just iota. So we now have 1 divided by iota to the power 25 equals 1 divided by iota. So now we have 1 divided by iota to the power 25 equals 1 divided by iota. This is a much simpler form and will help us as we continue solving the original expression. Therefore, 1 divided by iota whole to the power 25 equals 1 divided by iota. To simplify, 1 divided by iota whole to the power 25. So let's first look at 1 divided by iota. So we can rationalize the denominator by multiplying both the numerator and denominator by iota. Okay. So this gives us 1 divided by iota times iota divided by iota. This step is important because it helps us write the expression in a standard form without iota in the denominator. So now let's carry out the multiplication. So 1 divided by iota times iota divided by iota becomes iota divided by iota square, or iota divided by iota square. Here iota square is basically square root of minus 1 whole square, that is minus 1. So iota divided by minus 1, which is equal to minus iota, since iota square is minus 1. Now let's substitute the values we have found back into the original expression. So we know iota to the power 18 equals minus 1, and 1 divided by iota whole to the power 25 equals 1 divided by iota. And so after simplified, we get 1 divided by iota whole to the power 25 equals minus iota. So iota to the power 18 plus 1 divided by iota whole to the power 25 whole to the power 3 equals minus 1 plus minus iota whole to the power 3, which is equal to minus 1 minus iota whole to the power 3. Next, we can factor out minus 1. So we get iota to the power 18 plus 1 divided by iota whole to the power 25 whole cube equals minus 1 to the power 3 times 1 plus iota whole cube. So we simplify, minus 1 whole to the power 3 equals minus 1. Okay, so minus 1 to the power 3 times 1 plus iota cube equals minus 1 times 1 plus iota whole cube. So using here binomial formula, the formula is a plus b whole cube equals a cube plus b cube plus 3ab times a plus b. Here substituting a equal to 1 and b equals iota, we get minus 1 times 1 cube plus iota cube plus 3 times 1 times iota times 1 plus iota equals 1 plus iota cube plus 3 times iota plus 3 times iota square. First, let's recall some important properties of the imaginary unit. So we know that iota cube is minus iota and iota square is minus 1. Now let's substitute and simplify the powers. So we have iota to the power 18 plus 1 divided by iota whole to the power 25 whole cube equals minus 1 times 1 plus minus iota plus 3 times iota plus 3 times minus 1, which is equal to 1 minus iota plus 3 times iota minus 3. Now combine the real and imaginary terms together. So iota to the power 18 plus 1 divided by iota whole to the power 25 whole cube equals minus 1 times 1 minus 3 plus minus 1 plus 3 times iota. Let's finish the calculation. So for the simplifying, we get minus 1 times minus 2 plus 2 times iota, which is equal to 2 minus 2 times iota. This is our final answer. Therefore, the value of iota to the power 18 plus 1 divided by iota whole to the power 25 whole cube is 2 minus 2 iota. Now let's look at question number 2. So in this question, we have two complex numbers z1 and z2, and then we have to prove that real of z1 times z2 equals real part of Z1 times real part of Z2 minus imaginary part of Z1 times imaginary part of Z2. So let's start the solution of this question. So first of all, let's define our two complex numbers. We will let Z1 equals x1 plus iota times y1 and Z2 equals x2 plus iota times y2. Here x1 and x2 are the real parts and y1 and y2 are the imaginary parts of Z1 and Z2 respectively. Now let's clarify what x1 and x2 represent. Okay, and x1 is the real part of Z1 and x2 is the real part of Z2. So whenever you see x1 or x2 in our equations, so remember they stand for the real components of our complex number. Similarly, y1 and y2 are the imaginary parts of Z1 and Z2. That means y1 is the imaginary part of Z1 and y2 is the imaginary part of Z2. Next, let's find the product of these two complex numbers Z1 and Z2. So we will multiply them out using the forms we have just defined. So this the product of Z1 times Z2. So we know that if Z1 equals x1 plus iota times y1 and Z2 equals x2 plus iota times y2, then Z1 times Z2 equals x1 times x2 minus y1 times y2 plus iota times x1 times y2 plus y1 times x2. From this result, the real part of the product Z1 times Z2 equals x1 minus x2 minus y1 times y2, okay, plus iota times x1 times y2 plus y1 times x2 is the term without iota. We get real part of Z1 times Z2 equals x1 minus x2 minus y1 minus y2. Now substitute back the meanings of x1 and x2, y1 and y2. Since x1 is real part of Z1, x2 is real part of Z2, y1 is imaginary part of Z1 and y2 is imaginary part of Z2. So we can write real part of Z1 times Z2 equals real part of Z1 times real part of Z2 minus imaginary part of Z1 times imaginary part of Z2. So we have shown step by step that the real part of the product of two complex numbers is equal to the product of their real parts minus the product of their imaginary parts. Hence, proved. Now, let's examine question number 3, which asks us to reduce a complex expression to standard form. So, the expression is 1 divided by 1 minus 4 times iota minus 2 divided by 1 plus iota times 3 minus 4 times iota divided by 5 plus iota. So let's start the solution of this question. First, let's define our variables. So let z be the entire expression. So z equals 1 divided by 1 minus 4 times iota minus 2 divided by 1 plus iota multiplied with 3 minus 4 times iota divided by 5 plus iota, which is equal to z1 times z2. So we will call the first part z1 and the second part as z2. So z equals z1 times z2. Now let's focus on simplifying z1. So we have z1 equals 1 divided by 1 minus 4 times iota minus 2 divided by 1 plus iota. So to combine these two fractions, we need a common denominator. So we write it as z1 equals 1 divided by 1 plus iota minus 2 divided by 1 minus 4 times iota all over basically 1 times 1 plus iota minus 2 times 1 minus 4 times iota divided by 1 minus 4 times iota times 1 plus iota. Let's expand the numerators and the denominators. So the numerator becomes 1 plus iota minus 2 plus 8 times iota, and the denominator becomes 1 plus iota minus 4 times iota minus 4 times iota square. Now let's simplify further. So the numerator simplifies to minus 1 plus 9 times iota, and the denominator simplifies to 1 minus 3 times iota minus 4 times minus 1, since iota square is equal to minus 1. So after simplifying, we have z1 equals minus 1 plus 9 times iota divided by 5 minus 3 times iota. Therefore, z1 equals minus 1 plus 9 times iota divided by 5 minus 3 times iota. Now, let's focus on the combined expression after simplifying the individual fractions. So we have z equals minus 1 plus 9 times iota divided by 5 minus 3 times iota multiplied with 3 minus 4 times iota divided by 5 plus iota. Next, we multiply the numerators and the denominators directly. So this gives us z equals minus 1 plus 9 times iota times 3 minus 4 times iota divided by 4 minus 5 minus 3 iota times 5 plus iota. Let's expand both the numerator and the denominator. So the numerator becomes minus 3 plus 4 times iota plus 27 7 iota minus 36 iota square divided by 25 plus 5 times iota minus 15 times iota minus 3 times iota square. Now let's simplify using the fact that iota square equals minus 1. So the numerator becomes minus 3 plus 31 times iota minus 36 times minus 1, and the denominator becomes 25 minus 10 times iota minus 3 times minus 1. After combining like terms, the numerator is 33 plus 31 times iota, and the denominator is 28 minus 10 times iota. So our simplified expression is 33 plus 31 times iota divided by 28 minus 10 times iota. To simplify the expression, we need to get rid of the complex denominator. So we do this by multiplying both the numerator and denominator by the conjugate of the denominator, which is 28 plus 10 times iota. So our expression becomes z equals 33 plus 31 times iota divided by 28 minus 10 times iota multiplied with 28 plus 10 times iota divided by 28 plus 10 times iota. Now, let's expand the numerator and denominator. So, in the numerator, we multiply 33 plus 31 times iota by 28 plus 10 times iota. And in the denominator, we use the formula a minus b times a plus b equals a square minus b square. So, the expression becomes 924 plus 330 times iota plus 868 times iota plus 310 iota square divided by 28 square minus 10 iota whole square. Since iota square is minus 1, so we use this, and for the simplify, we get z equals 924 plus 1198 times iota plus 310 times minus 1 divided by 784 minus 100 times minus 1. After simplifying, we get 614 plus 1198 times iota divided by 884. Finally, by separating the real and imaginary parts, we get Z equals 614 divided by 884 plus 1198 divided by 884 times iota. Next, let's simplify further. We get Z equals 307 divided by 442 plus 599 divided by 442 times iota. Therefore, our final answer in standard form is Z equals 307 divided by 442 plus 599 divided by 442 times iota. So this shows the real part is 307 divided by 442 and the imaginary part is 599 divided by 442. That's all for today's lecture. So thank you for your attention. I hope this lesson was helpful to all of you.